Okay, here's a question from May 2013. It's question 3. It's all about speed, time and distance, and it's called Mikhail's running trip. It says Mikhail runs several times a week. On his running trip, he takes a mobile phone with a program that can measure how far he runs and how much time he spends running. After each running trip, Mikhail gets the measurements shown on a curve, and then there's an example of such a curve here. The curve below shows the mobile telephone's measurements after one of Mikhail's running trips. Read from the curve how much time Mikhail was running for and how long he ran. So it's all the way up to the end of the curve where he stops running, and that's 5 kilometers, and it's 24 minutes. Next question. What was Mikhail's average speed in kilometers per hour on the first kilometer of the running trip? Okay, so look at the curve again, and the first kilometer, there it is, 1 kilometer took him 5 minutes. So on our rough paper, we're saying 1 kilometer in 5 minutes, a fifth of a kilometer or 0.2 of a kilometer in 1 minute. And once you've worked out how much in 1 minute, you can work out how much in 1 hour, 60 times as much. So it's 12 kilometers in 1 hour. And you worked out 12 kilometers from 1 times 60 divided by 5 effectively. So 12 kilometers per hour. Next part. On another day, Mikhail runs 5 kilometers in 25 minutes. On the way, he had to stop 2 times for a red light, and he ran fastest on the last kilometer of the run. Draw a curve that shows how the mobile telephone's measurements could have looked after this running trip. So there's lots of ways you could have answered this, but here's an example. So you've got him running for a bit, and then it's flat where he had to stop, running for a bit again, then it's flat where he had to stop, and then he's running again, and then the last kilometer, so from 4 to 5 here, is the steepest part of the graph because that's where he's running the fastest. So it's steeper than any of these other parts where he's running. So to get the full marks for this, you need 3 basic things, apart from everything being in the right place and it ending at 25 minutes and 5 kilometers. You need the 2 flat sections, and you need the last kilometer from 4 kilometers to 5 kilometers to be steeper than any other section of the graph. As long as you've got those features, then you're getting the mark for that. Question 3.4, draw a curve that shows how the mobile telephone's measurements would see if Mikhail had run 5 kilometers at a constant speed of 15 kilometers per hour. Okay, so I'm looking at my graph now, and I'm going to my rough paper, and I'm saying, okay, 15 kilometers per hour, that's 15 kilometers in 1 hour. If he did 15 kilometers in 1 hour, then he would be doing 5 kilometers in 20 minutes. I've just divided everything by 3 there. So at that speed, where he's going 15 kilometers per hour, 5 kilometers would take him 20 minutes. And we're talking about him running 5 kilometers. So we need the graph to show 5 kilometers in 20 minutes. And there it is. (3.5) suggest a formula for the function that describes the linear relationship. Well, you should have done a lot of work now on straight lines and their graphs. So straight line graphs usually have an equation like y equals something x plus something, and it's all to do with how steep the curve is and where it cuts. Now, let's have a look at how steep the curve is. Well, first of all, it cuts at 0, but looking at how steep the curve is now, it's going 0.25 up for every 1 across. Now, it's hard to try and read a single unit on this, but if you think about the fact that it's going 5 up for 20 across, then it's going 2.5 up for every 10 across, and you can figure out that it's going 0.25 up for every 1 across. So you're not trying to read a little section of the graph where it's just going across by 1 and you've got to figure out how much it's going up. Think about the bigger graph and figure it out from that. So because it's gone 5 up for 20 across, I can figure out that it's going 0.25 up for every 1 across. And as I said, it cuts at 0. So the equation of the graph is going to be y equals 0.25 times x, where x is the time in minutes and y is the length in kilometers. So 0.25 for x for the gradient, the number in front of x is always the gradient, the steepness, and then nothing on the end, so in other words plus 0 on the end because it cuts at 0. Now really you should say what x and y are here, because there's no x and y in the question, you just introduced them. So you ought to be either saying what x and y are, x is the time in minutes, and y is the length in kilometers, or you can just write your equation in terms of those things. So you can say length in kilometers equals 0.25 times time in minutes. So there's my answer sheet, everything neatly lined up. Now I'm a bit concerned about here where I've just written y equals 0.25x without saying what they are. I might lose a mark for that. And here's the marks you could get for that, and it's 4 marks for each part of the question.